Hello, I'm Dr. Thomas Hitchcock, and welcome to this episode of Beauty and the Bacteria, an exploration into the world of the skin microbiome. In this series, we're taking a closer look at the entangled nature of our skin's relationship to the microbes that live on and in the skin, and how that affects our lives from birth to death. The foundation of what we discovered in the last episode takes us to what I want to discuss with you today. In this episode titled Scratching the Surface, we'll be looking at how our skin's microbiome actually begins, evolves, and then persists. We'll take a look at how the extent of the access of the skin microbiome to our human cells is much more significant than we once thought. And we'll be looking at how a small number of microbes actually make up the bulk of the skin microbiome and how this is beneficial to us. When we look at the skin, it's easy to focus on the surface because that's what we can easily see. Certain attributes stand out, such as tone or color, or whether there is abnormal tone or color with melasma or age spots, or texture, such as if there's scar tissue, large pores, or fine lines. While many aesthetic procedures attempt to correct these, what many might consider flaws, by manipulation of the skin surface, these so-called flaws are often manifestations of biological actions deeper within our physiology. And when it comes to the skin microbiome, it is similarly true. We tend to focus on the surface of the skin, what microbes reside there, and how we might modulate those microbes with cleansers, topicals, exfoliants, you name it, when we must realize that the microbiome of the skin lives not just on the surface, but throughout the depths of the entire skin and beyond. And what is beneath the surface may be just as important. So where does our skin's microbiome come from? Is it simply an accumulation of things we touch in life? When we're born, where do the very first skin microbes come from, and does it matter? It was thought until very recently that a person's development in the womb took place in a sterile environment. Because of this, it was thought that the seeds of our body's microbiome came from our mothers by the way of the birth canal through which we all enter the world. Well, some of us anyway, as there are those who don't enter the world vaginally, but rather through cesarean section. Now, we could attempt to theorize how those born by cesarean section received their first microbes and what impact they may have on their development and health, but we won't, because a significant amount of research has shown that the womb is actually not a sterile environment, and that we are exposed to a number of species of microbes while we are in the womb. So, how is it that we are just finding this out now? Well, remember from our Microbiome 101 episodes that some microbes are not easily culturable in a lab. And so it wasn't until we had 16S sequencing tools in our arsenal that we were able to thoroughly analyze samples for a complete microbial fingerprint. So yes, even before we are born, we are literally swimming in bacteria. Now, research is showing that there are limitations to the strains and numbers of bacteria that are in the womb. But if we look at this table of bacterial types that are isolated from amniotic fluid, we can identify some of the main species of skin microbiota that stay with us throughout our lives, namely C. acnes and Staph epidermidis. While scientists are still figuring out the answers to questions like how and when these microbes enter the uterus during gestation, where they come from, whether they are alive and replicating or dormant, and what function they play during development, we at least are now seeing how the skin is first introduced to the microbes that we will then need to learn to live with. And now that we know that we aren't born sterile, it does make sense. If we were sterile and born into a world teeming with microbes, our immune system might go into shock or overreact during a critical period in life. As an example, this has been theorized to be the potential cause of erythema toxicum neonatorum, a rash that develops on some newborns. While the cause is not definitively known, it is thought that it could be an immune response to the microbes colonizing the hair follicles. Remember that only a small number of microbes are found in the womb and only select microbes. So as we enter a world full of foreign microbes, we are bound to meet a new friend, or a million, in the very first minutes of life. However, having exposure to low levels of commensal microbes in utero may allow the fetal cells and immune system to grow accustomed to these microbes. So, we are born with a skin microbiome, but it doesn't stop there. Colonization of microbes continues as we mature until it begins to stabilize in adulthood. Does this mean we have a limited time to make up a healthy microbiome, or do we even have the ability to influence how our microbiome develops? These are the questions researchers are attempting to answer so that in the future, we can glean all the benefits of a symbiotic skin microbiome throughout our entire life. It is estimated that at least 1 million bacteria with hundreds of distinct species inhabit each square centimeter of our skin. Now, such an estimation may vary based on how samples are taken from the skin, but just as we learn that we are not sterile in the womb, we're also learning that the methods by which we sample the microbiome should evolve over time as we learn more about the science, and what possible deficiencies our sampling techniques currently may have. This is something that all microbiome scientists must consider in their research. Most studies sample the skin microbiome by taking a swab of the skin. However, we must ask ourselves if that truly represents the microbiome as a whole, or if it simply shows what's on the surface. Consider this. From a macroscopic level, skin looks pretty much like a flat surface, a sheet that covers our bodies. But we know that when we can look closer, we start to see that the skin is much more complicated. We have millions of pores on the skin that appear as small holes, but are actually the entrances to cavernous hair follicles. Well, I suppose the word cavernous is relative here, since one might not consider a pore cavernous in size, but some of us might feel that way when we're looking in the mirror at times. But in relation to the skin pore or hair follicle, it can extend from the surface of the skin all the way through the entire thickness of the skin layers and into the fat or subcutaneous layers under the skin. So if we consider how much surface area of skin microbes have access to, we must not only consider the outermost surface, but the surface area of all 5 million or so hair follicles. For many years, it was assumed that the gut, with its abundance of epithelial-lined microvilli, had a surface area much larger than skin for direct access of the microbes in the lining of the gut to human cells, with an estimated surface area of 30 meters squared versus the skin's supposed surface area of 2 meters squared. However, current thinking is that this is not the case. In an article by Dr. Rich Gallo in 2017, he proposes this calculation. You're welcome to pause the video here and do the math yourself. But if you're willing to trust Dr. Gallo, the general idea is that the total skin surface area is not 2 meters squared, but is actually closer to 30 meters squared. If this calculation is indeed correct, then the interface of the skin and its microbiome becomes one of, if not the most significant of the organs. Even more interestingly, because the vast bulk of surface area calculated is due to surface area within the hair follicles, then what lies beneath the surface carries that much more importance. So what microbes are on the surface, and which ones lie beneath? When we take a swab from the skin, it can be noted that in adults, the skin bacteria belong into 4 phyla, which is plural for phylum if you recall our discussion on taxonomy. Actinobacteria makes up 51.8%, Firmicutes 24.4%, Proteobacteria at 16.5%, and Bacteroidetes at 6.3%. Of those phyla, the bacteria composition of the skin is mostly dominated by the genera, which is the plural for genus, Cutibacterium at 23%, Corneobacteria at 22.8%, and Staphylococci at 16.8%. Although these 3 are the main types of skin bacteria that make up the bulk of the skin microbiome, most skin-related species make up less than 1% of the total microflora in any given skin site. However, that doesn't mean that they are any less important, or that they can't impart significant benefit or harm. Remember, it's not necessarily the presence of a microbe that causes benefit or harm, but also the substances that they produce. If you remember that some microbes make substances such as endotoxins, a little can have a large impact. However, sometimes the amount of microbes of a given species is important, especially when the molecules that they secrete produce a protective benefit, such as the antioxidants produced by C. acnes. Altogether, there are thousands of species that can live on the skin, but it is known that some of the microbes that live on the surface may be transient in nature, meaning if you touch something, you may take some of those microbes that cover that object onto yourself. However, unless those microbes are able to find the area of your skin hospitable, meaning it can find the right food, location, pH, etc., then it will eventually either die or simply shed with your dead skin cells. Just because a microbe finds its way onto the skin doesn't mean it will become part of the microbiome. When a given microbe strain does end up taking and becoming part of the microbiome, we call that engraftment. When we look at the palm microbiome, for instance, a study found over 4,000 distinct species in 51 healthy subjects, with an average of 158 species coexisting on a single palm. One may wonder how many of those species were transient and how many are a true part of the palm microbiome. We call this change in types of species of microbes over time in any given area of the body temporal fluctuation or temporal variance. Different skin sites have different levels of temporal fluctuation. Moist sites like the axilla or armpit that aren't directly exposed to objects we touch tend to have more stable bacteria communities over time, while drier and more exposed skin sites, such as the palm, seem to have higher diversity of types of microbes and more changes to those over time. So a palm would have a higher temporal flux as compared to the axilla. Another term we use when we describe the differences in microbiomes between skin sites is alpha and beta diversity. Alpha diversity is the measure of how many different types of species lives in a given area on the person, while beta diversity is the measure of the differences of the microbiome composition of any given site when comparing between different people. For example, a study showed that the cubital fossa or elbow pit had a highest variance of microbiome species when comparing samples from different people, so it has a very high beta diversity. However, the same site on the body typically has very few unique species that compose that part of the microbiome, so it has a small alpha diversity. Measurements like temporal flux, alpha and beta diversity can give us ways to assess the characteristics of any given microbiome within a particular area of the skin and how it functions. This is important to knowing how any given microbiome species might contribute to health or disease, and how we might use that to our benefit. For instance, we can take a look at any given microbe and how it acts in that area of skin. Does it have a high temporal flux, or does it stay put when present? Does it have low beta diversity, meaning is it present in most people at any given skin area or only on a few people? These things will tell us how easy it would be to either get rid of any particular pathogenic strain or how easy it would be to engraft any particular beneficial strain that might be therapeutic, so it would colonize the skin. That being said, once a microbiome is established, it is not typically easy to cause a permanent change to that microbiome. This is observed in studies where benzoyl peroxide is used to reduce the overall number of bacteria on the face transiently. However, what is observed after doing this is that the types and proportions of the bacteria that existed on the face initially eventually took up residence again. So, while alteration of the microbiome may be a cool idea for potential therapeutic applications, it is not as easy as one might think. However, it is possible with long-term consistent use of the right products and habits. We'll cover this more in later episodes as well. As we discussed in Microbiome 101, different sites of the skin have different types of environments that tend to attract and foster different types of microbes. Similar areas, such as the axilla and the back of the knee, tend to foster similar microbes, as they are moist areas that tend not to be disturbed frequently, nor do they often encounter foreign objects with their own microbes. Staphylococcus and Corneobacterium species dominate moist areas such as these, while Cutibacterium species dominate sebaceous areas like the face and the back. But again, all this is based off of studies looking at swabs of the surface. But what if we were to also sample what's beyond the surface, to what's inside the skin? What if we were to look deeper? And that is just what we'll do in the next episode, where we'll continue this discussion by looking deeper. As always, we want to hear from you, so please send your questions, comments, or topics you'd like us to cover to comments@beautyandthebacteria.com. You can also follow us on social media listed here, to watch our Q&A sessions, interviews, or to send us your questions and to receive updates on this series, as well as other news and information on skin microbiome initiatives at Crown. From all of us here at Crown Laboratories, thank you for watching. And remember, you have billions of bacteria on your face, and we think that is awesome. Goodbye for now.